Hello, my name is Hmt Hw, and this is Hmt Hw for homework 5. So for problem 4-43, it is determined to figure out what the temperature of the ball, not temperature, heat of the balls are. We assume constant thermal properties. After determining what the BO number is, right here, we determine that we can do lumped analysis. So we figure out all the parameters for it, plug values in, and determined that the time for the annealing process is 2.7 minutes. And then we have to determine the total rate of heat transfer from the balls to the ambient air. And so we have to figure out what it is per single ball, which I did here, and then multiply times the number of balls and get the heat rate transfer. And then let's see, problem 4-100. Asks about the soil temperatures distances from at different depths, and so we assume constant thermal properties. 1D transient equations here. I used Excel to determine a lot of the things in this problem. Figured out just some parameters. I determined the limits from Excel and from class, and so from that we were able to simplify the temperature distribution. And then I solved for all the different temps, all the different depths via Excel, and these are what they are here. And then for 4-115, I believe it's an ice cube that's melting. Yeah. So we can say that the temperature varies in X and Y, thermal properties are constant, so it's 2D transient. Before doing anything, I decided to figure out what tau was and made sure that it was greater than 0.2. And then from that, we were able to figure out the BO number, figure out the different parameters, and just plug it into the appropriate equation. And for the last problem, 14-89, basically, we were able to use the semi-infinite model because it was a diffusion process, which is at a very thin layer at the surface. And from that, we just plug our numbers in and simplify, and then we get different depths after a certain amount of time.